Hello bachcho, how are you? I hope you all are good. Now see our next our topic we are continue. Okay, whatever content of our topic in that acid, bases and salts. Okay, so acids, bases and salts we completed all theories. Okay, so now we are moving forward. Okay, so that point whatever we are discussing now. Okay, preparations of acids. What beta? Preparations of acids. So basically so many methods, different methods of preparation of acids. Okay, so simple methods also there. Okay, in that we will discuss first by direct combination, by direct combination. Okay, by direct combination method. Okay, or we can say what? Synthesis, by direct synthesis. Okay, so see here what will happen. Generally, see H2 gaseous plus Br2 gaseous. So it gives what? Simple, you will get acid HBr only. Means basically this method, direct combinations, it is basically what? For binary acids. Okay, binary means two, whatever elements are 2, 1 and 2. Okay, hydrogen Br. Okay, so see here H2 gaseous plus Cl2 gaseous. Okay, so what you will get? Yes, HCl. Okay, so whatever you will get is in what? Beta, in liquid form. Okay, these are what here? Yes, these are what? Direct combination method. So for balancing, so see here 2H2 Br2, so like that we can balance. Understood? This what? Direct combination, or we can say synthesis. Okay, now we will see our next method. First we saw by direct combination, now second by double displacement. Okay, second by double displacement. Okay, so in double displacement what will happen? So as you know, so many examples beta. So see here your NaCl plus H2SO4. Okay, NaCl plus H2SO4. So here what will happen? See here what will happen? NaCl plus H2SO4. Beta, here we are preparing what? HCl. So as you know, wherever necessary, wherever possible, we will breaking. Okay, we will break that. So Na plus Cl minus, here H plus SO4 2 minus. So what will happen here? Na2SO4 plus HCl. Got my point here? So for balancing, take here 2. Okay, here also 2. Understood? So these are what? Preparation of acids from double displacement method, or by double displacement method. Okay, so whatever now next we will discuss third. Okay, with the help of acetic oxide. Okay, with the help of acetic oxide also we are preparing your acid. Okay, so see here whatever third. So in that third, by the reaction of acidic oxide, with water. So you are ready, whatever your acidic oxide. So see here beta, acidic oxide, yes, SO3 gaseous plus H2 what you will get? Oxide, acidic oxide plus H2O. So here simply you will get, yes, H2SO4. Understood? And suppose if you take CO2 gaseous, what beta here? CO2 gaseous plus H2O. What you will get? Yes, H2CO3 you will get. Means here you will get beta sulfuric acid. Yes, sulfuric acid here you will get. And here what beta? Yes, carbonic acid you will get. Means these are few methods of what? Preparation of acid by direct. Then we saw our whatever next with the help of displacement. Now what? With the help of acidic oxide we can prepare. So basically these are what? Acidic oxide means what we are saying? These are anhydrides. Okay, whatever this, suppose this SO3, these are what is acidic oxide? Yes. What we call this as a acidic oxide, but we call this as a anhydride also. What beta? Anhydride. So this whatever this word is new for you, beta. Anhydride. Anhydride means, say suppose H2SO4. So if by mistakenly if whatever fumes, okay, indirectly went in our mouth. So what will happen, beta? In that, okay, whatever H2SO4, whatever water content from this, okay, so water content it will take out immediately. So immediately in Marathi we call it as the what? Taska. Okay, we म्हणजे आपल्याला काय येणार लगेच ठसका येतो. Okay, so whatever means water content from this throat, so immediately take out that H2SO4 fumes. So anhydride means what? Yes, removal of water. So from beta H2SO4, if you remove water, so what will you will get? You will get SO3. Okay, so we call it as a what? Anhydride also. Okay, anhydride of sulfuric acid, anhydride of carbonic acid. Okay, so understood whatever these preparation simple method here. Okay, now we will discuss here next one, that is properties of acids. Okay, you are ready with that? Properties of acid. So see here in properties, okay, properties of acids. So mostly either your acids are what? Yes, solid acids and somewhat what beta? Liquid acids. So we will whatever first here physical state we will discuss here. Okay, physical state of acid. Okay, most of your acids are solids and liquid acids. Okay, so we will concentrate, we will see here some example. Okay, so acid and their physical state, acids and here what beta? Physical state. So we will compare here some acids. Okay, you are ready with this? So see first, okay, first here beta, yes, boric acid. Okay, boric acid, as you know, H3BO3. H3BO3, boric acid. Okay, so next see oxalic acid. Oxalic acid is what? H2C2O4. I am giving here molecular formula also because it will help for your higher standard. Okay, oxalic acid. Then your what beta? Tartaric acid. Okay, tartaric acid having a formula C4H6O6. Yeah, these are what beta? Molecular formula. They have a structures also. Okay, so first we will concentrate on whichever acids are solids. Okay, so these are what beta? Solid acids. What beta here? Solid acids. Okay, one of the another also acid, citric acid. Yes, citric acid. So see C6H8O7, their molecular formula. Okay, so these are what beta? All these are, so all these are what? Solid. Physical state is what beta here? Solid. Okay, now we will move towards, in that your phosphoric acid also solid. Okay, whatever H3PO4 is also your solid. Okay, so we will discuss here some whatever your liquid acids. So liquid acid also there. So liquid acids, as you know, in that suppose if you are going to discuss here liquid acids, so say liquid acids. First, yes, acetic acid. Okay, as you know this. Second, your sulfuric acid, H2SO4. Then what beta? Yes, nitric acid, HNO3. Okay, these are what beta? Your liquid acids. Then HCl also there. Okay, these are what simple your whatever physical state of your acids, or we can say what in the properties of acid we are discussing this small point as a physical state. Okay, with an example we saw. Okay, now we will discuss here our next property. Whatever your acids, they changes color with the indicators. Okay, whatever second property, acids changes color with, yes, with indicators. So basically whatever these indicators, so indicate means what? Indicate which color acids they are giving. Okay, indicating that color. So we call it as what? Indicators. It means we can easily observe whether it is acid is present in that solution or not, or something any else present in, okay, whatever in solution, either acid, basic. Okay, so basically your indicators are what? Complex substances. Okay, so see here they acquire different colors. Okay, in acidic or basic medium, whatever your indicators, they acquire what? Different colors in acidic and basic medium. Okay, so what purpose of these indicators? Whether that solution is acidic or basic. Okay, so with color we can easily observe. So we will discuss some here. So say indicators beta. Okay, and color change in acidic medium. Okay, color change in acidic medium. Okay, so see here how we can see this. So that in practical one special video I will make. Okay, for your this how they will change on adding acids and base with indicators. Okay, so we will see first beta litmus solution. Litmus solution. So how it will change? Yes, it will change what? Blue to red. Yes, blue to red. So here we are discussing simple property. So next beta methyl orange. So in methyl orange, so basically original color is what? Orange. So in acidic medium it changes what? Orange to red. Okay, third one we will discuss. Yes, third one is what beta? Phenolphthalein. Yes, phenolphthalein. So in phenolphthalein your color remains same. Okay, remain same, unchanged, or we can say what? Colorless in acidic medium. In what beta? In acidic medium. Understood? So these are very much important here. Whatever means your whatever your acid that changes color. Okay, changes the color with indicators. Okay, so these are few examples. I will make here one separate video for this. How different acids they are changing color in acidic as well as in basic solution. Okay, so we will move towards next. So as you know beta, whatever your acids, so acids are what? Yes, acids your good electrolytes. Okay, whatever your acids, these are what? Acids are good electrolytes. So beta, electrolytes, when it is possible to show this property, electrolytes, yes. So beta, presence of, okay, what beta? Presence of free ions in your acids. Then only it conducts what? Electricity. Okay, so many examples as you know in car batteries, lead storage battery, H2SO4 is present. Okay, so next we will discuss. So what a property beta? acids are corrosive in nature. Acids are what, beta? Corrosive in nature. So it is also one of the property of your acid. Okay, so whatever we discuss property, so these all are important. Okay, so you revise that property. Now we will discuss, yes, now we will discuss beta chemical property. Yes, chemical properties of acids. Okay, so here very much interesting to know this. In small a we will discuss chemical properties of acids. So acids, okay, so reaction with active metals, how it behaves. Okay, a reaction with, yes, active metals. Okay, so reaction with active metals, as you know beta, whatever your acids evolve H2 if they will react with what? Active metals. Okay, in electrochemical series, sorry, in reactivity series or activity series. So whatever I saw, whatever I told, electrochemical series, it is in 12th standard electrochemical series. Okay, sorry for that. So whatever we discuss in reactivity series or activity series, okay, are you remembering that all? KB Nath Kamali and all. Okay, so it is very much important. So what I told here, acids evolve H2 gas easily with active metals like sodium, potassium, iron also. Okay, so we will discuss that also. But beta here one of the interesting whatever this term. Okay, so see here whatever interesting term. Dilute HNO3, okay, is a strong what? Oxidizing agent due to released H2 gas gets converted into H2O. Okay, converted into what beta? H2O. So here simply means we are saying what we are saying. Okay, all whatever acids it reacts with active metals, but when beta dilute HNO3 it will react. So it will not react with your metal. Okay. So what will happen? Basically, because dilute HNO3 is what? Strong oxidizing agent, and whatever release H2, so obviously it will release H2 when metal reacts with acid, it will release H2. But in case of dilute HNO3, one of the exceptional case we can say, okay, what will happen? Dilute HNO3, it will oxidize. Okay, oxidation will occur. So become whatever H2 gas released in that reaction, it will convert into H2O. Okay, suppose zinc plus HNO3. So if you saw it in that zinc plus nitric acid, it will never release H2. It will what? Zinc nitrate, H2 and NO2. It will. Okay, so like that, one of the this same reaction we will we discuss in metals and non-metals also. Okay. So please pay attention. Okay, then immediately you correlate. Comparatively study always helpful. Okay, so see here reaction with active metals. So see this metal plus your H2SO4. So what you will get? Yes, FeSO4 plus H2 gas. Okay, it will evolve easily here. Suppose here Zn means what we conclude here, generally whatever HCl and H2SO4 we can use, not a nitric acid, because your nitric acid is what? Strong oxidizing agent. So keep in mind. Okay, so Zn plus HCl, suppose if you have to write this, so what will get beta? ZnCl2 plus H2 gas. So 2HCl, yes, our reaction is balanced. Okay, so we will move towards next in that chemical properties of acids. Okay, I hope you understood all. Now see here, so whatever one special here point I'm going to discuss here. Okay, so we call it as a note, also important note, or we will perform this in our lab also. Okay, see here what will happen, beta. Okay, first, if you have lime water is what, beta? Calcium hydroxide. So see here, this calcium hydroxide, okay, aqueous form. When, okay, if you pass, beta, here CO2 gas, so obviously what will happen? You will get here precipitation of CO3 plus what, beta? H2. So here you will get what, beta? Solid. Here precipitate, white precipitate you will get. Okay, and as you know that white precipitate is what? Always insoluble. Okay, understood? So here one of the means so many questions asked on this whatever contain calcium hydroxide plus if you pass CO2 gas, so you will get white precipitate of calcium carbonate. And if you further pass CO2 gas, okay, so see here, CaCO3 solid plus H2, okay, so that as you know that H2 is in what, beta? Liquid, plus CO2 means excess of CO2 gas if you pass, so what you will get? Yes, you will get calcium hydrogen carbonate. What you will get? Calcium, okay, calcium hydrogen carbonate or calcium hydrogen carbonate, calcium bicarbonate. This what with HCO3 is bicarbonate ion here. Calcium, or we can write here, okay, so see here, or we can write calcium bicarbonate. Understood? So whatever, if you pass CO2 gas, so whatever that precipitate, whatever your that precipitate is, slowly disappear. Okay, slowly what will happen, beta? Disappear. Okay, so it is one of the important here. Most of the time they ask question on this concept. Okay, calcium hydroxide, if you pass CO2, then calcium carbonate precipitate, and further if you pass CO2 gas, excess passing, then what we will get? That precipitate will disappear. Okay, so keep in mind all this. Okay, now we will discuss in chemical properties of acids. So we will discuss some reactions. Reaction with the metal oxide with acids. Okay. See here, reactions of acids with, yes, with metal oxides, with metal oxides. So generally if you are writing, so metal oxide plus acid, metal oxide plus acid, yes, what you will get? You will get, beta, salt plus water. What? Salt plus water you will get. Okay, so see, calcium oxide plus HNO3. So what you will get? Yes, positive negative valency. They will attract and forming a new formula. Yes, so see, new stable compound, calcium nitrate plus what, beta? Water only. So for balancing, yes, for balancing here you have to write here 2, 2, 3 the 6, yes, hydrogen also balance. Understood? So these are what, beta? metal oxide with acid. Now suppose if you are taking CuO solid plus H2SO4, so what you will get? Immediately you will get what? CuSO4 plus H2O, aqueous. Okay, so metal oxide reacts with acid like a similar, as you know, similar to reaction with base. Okay, whatever your base reacts with acid, so base reacts with acid, what you will get? Salt. Means we call it the what? Neutralization reaction. Okay, what we call beta here? Neutralization reaction. Okay, means it was similar product you will get, salt plus water. NaOH plus HCl, you will get what? NaCl plus water. So salt plus water you will get. Okay, so we will move towards next reactions. Okay, so see what we have to discuss here. Reaction with metal bisulfides and sulfides. Second, we will discuss reactions of acids with metal bisulfides and metal sulfides. So for that you must know what is a bisulfide and sulfide. Bisulfide and sulfide. Okay, so sulfide is SO3 2 minus, and bisulfide is what? HSO3 minus only. So you have to concentrate, this must know, sulfides and sulfides, bisulfides and sulfide. So we will take here one example. Okay, so see here that example. First we will write general reaction. So see how it is your general reaction. Beta, metal sulfide bisulfide plus acid, you will get what? Yes, you will get salt of that plus SO2 gas plus water you will get. Understood? So you have to keep in mind this. Okay, you have to keep in mind metal sulfide and bisulfide, you will get what? SO2 gas, obviously SO2 gas will release. Okay, suppose if you are considering one example, calcium sulfide. So beta calcium sulfide plus acid, if you take one acid HCl if you take. So as you know, which salt you will get? Yes, Cl2 plus SO2 gas will release plus what beta? H2O. So for balancing, take here 2. Yes, our reaction is balance. Okay, so like that, simple here reaction, but you must know here whatever formulas, chemical formulas of that, all your anion part, cation part. Okay, suppose here we will take one example of bisulfite also. So see here, sodium NaHCO3. I already told the chemical formula of that, HSO3 minus. So plus HCl. So what you will get? Yes, here you will get salt plus what? Yes, SO2 gas plus H2O liquid. So see whether it is balanced or not. Yes, our reaction is balanced completely. Okay, so these are what? Reaction with sulfide, bisulfide plus acid. Okay, so we will discuss our next in that chemical properties with acids. Okay, so reaction with metal sulfides and bisulfides. reaction with metal sulfides and what? Metal bisulfides. Okay, metal sulfides and bisulfides. So beta here general reaction, if you are writing, so see here how we can write general reaction sulfide bisulfides. So you must know here sulfides means what? Yes, H2 minus, bisulfide HS minus. This much you know. Okay, in chemistry you must know everything, whatever formulae, chemical formulas, atomic number and all. These are basic requirement to study chemistry. Okay, so see here sulfides, bisulfides. Okay, see the pronunciation sulfides, bisulfides, DS, TS, but huge difference in their chemical formulas. Okay, so see here what you will get. We will write beta here general reaction. Metal sulfide bisulfide plus, yes, plus acid. What you will get? Yes, you will get what here? Salt you will get plus hydrogen sulfide gas. What you will get beta? Hydrogen sulfide gas, or we call it as the what? H2S gas. Okay, so we will take here example. You are ready with example. You make box for immediate highlighting. Okay, so whatever, if you must know the general reaction also, then you can write easily whatever reaction. Okay, so for that I am doing here box also, to easy to locate that, easy to remember everything. Okay, so see here metal sulfides. So ZnS plus, suppose if you take HCl or H2, suppose any if you take HCl, so what you will get here? Yes, ZnCl2 plus what? H2S. For balancing, take 2. 2 hydrogen, 2 Cl, other all are balanced. Hydrogen sulfide gas here evolve. Suppose if you write here APS plus. Okay, so see here FeS plus H2SO4. So beta, what you will get? Yes, you will get here FeSO4 plus H2S. And suppose if you are thinking for bisulfide, so see here, yes, NaHS bisulfide plus HCl. So beta, what you will get? Yes, NaCl plus H2S gas. So these are what? Reaction with what beta here? Reaction with sulfides, bisulfides. Okay, I hope you understood all whatever we taught in today's lecture. Okay, so whatever next thing we will discuss in next lecture. Okay, so remove your notes, send whatever doubts on WhatsApp. Okay, so thank you, stay safe, stay home. Thank you.